So we looked at parallel lines and transversals in which things are congruent and supplementary. So remember, our corresponding angles, alternate interior and alternate exterior, are all congruent, as well as vertical angles. Remember, vertical angles are congruent regardless of if lines are parallel or not. And then our consecutive interior, which is also same side interior, which is also called co-interior, those ones are supplementary. And then linear pairs are supplementary regardless of if the lines are parallel or not. Well, now we have the converse. The converse is where you switch the if and the then. So if we have if P, actually let's write it like this. So originally we had if P then Q. This would be if Q then P. So you're switching the hypothesis and the conclusion, or the if and then. So the other day we were looking and we said, if we've got parallel lines cut by a transversal, then we know they're congruent or supplementary. Oh, I totally missed doing that one. I forgot. I guess we'll look at it right now real quick. So if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other, which should make sense. Got two lines that are parallel. It's perpendicular to one of them, which means that it has to be perpendicular to this one as well because of corresponding angles. Okay. So that should make sense. Okay, now back to what I was saying. So we had if the lines are parallel, then we know, and cut by a transversal, then we know it's congruent or supplementary. So now we have the backwards way. So if we know that they're congruent, then we know the lines are parallel. So if two lines are cut by a transversal so that corresponding angles are congruent, so this time we didn't know that the angles or that the lines are parallel. So then we're going to check and see that they are parallel by the corresponding angles being congruent. So the corresponding angles, if they're congruent, then we know it's parallel. If the alternate interior angles are congruent, then we know that the lines are parallel. If the consecutive interior angles are supplementary, then we know the lines are parallel. Or if the alternate exterior angles are congruent, then we know that the lines are parallel. Okay. So all of those are the converse. So the converse is showing parallel lines, and then the originals are if you have the lines are parallel. Okay. So here we're going to have this additional one that we have, parallel to the same line theorem. So if two lines are parallel to the same line, so I say that these two lines are parallel, and then I say these two lines are parallel. So this line and this line are parallel to this one. Then we know that these two lines are also parallel, okay? Which should make sense. It's similar to our law of syllogism that you might have done, or your transitive property, but it's with a theorem in itself. Okay. So let's take a look. So here we want to find x so that lines u and v are parallel. Well, if we want u and v to be parallel, that means that I need these to be the same measurement. These are alternate exterior. So this would be, we would use the alternate exterior angles converse theorem, and we would have 110 would have to equal x plus 120. So then here, we're going to undo adding 120 by subtracting 120. So that gives us negative 10 equals x. And then we've got the x by itself, so we're all done. Now, if we go and we look, and if I plug in negative 10, that doesn't make our angle negative. It just makes this turn to 110. Okay? So if our x value is negative 10, then we know that u and v are parallel lines. Okay? If we look at this one over here, we've got that these two we don't know that they're parallel, but we're trying to show that u and v are parallel. So we want these two things. These are alternate interior. So we would use the alternate interior angles converse theorem. We know it's the converse because we're showing that u and v are parallel. So I'd set these two things equal to each other. So I would do 9 plus 8x equals 65. So then I would subtract 9. So we would get 8x equals 56. And then I want to undo timesing by 8 by dividing by 8. So then x is 7. So if our x value is 7, then we know that u and v are parallel. Okay? Now, compare that to what we did yesterday. So on this one, we knew the lines were parallel. Here, we don't know the lines are parallel. We're trying to show that the lines are parallel. Okay? So you're given different pieces of information. So here we know the lines are parallel. In this case, these two would be supplementary. So we'd solve by doing 11x plus 2 plus 2x plus 22 equals 180. As opposed to this one, it's saying what value of x here makes it so that these are parallel. Well, these would have to be the same measurement in order for these to be parallel. So I set them equal to each other. So it's similar in how we set up, right? So yesterday we were doing where we set them equal to each other or potentially supplementary. We're doing that same kind of thing, but the premise is different. So we're saying because in order for u and v to be parallel, these need to be the same measurement, right? So we're starting out with different pieces of information each time. So these, we knew the lines were parallel, so then we could say it's supplementary. In order to show that these are parallel, we need those two to be the same measurement. So in order for those two to be the same measure, we need the x to be negative 10. Or in order for these two, alternate interior, to be the same measurement, x needs to be 7, so then u and v will be parallel. Okay. So here we have A is parallel to B. So one of the things we're working on is marking up our diagrams. So A is parallel to B. We know B is parallel to C. So these two are congruent to each other. What can we say about A and C? Well, these are parallel and these are parallel, so that means these are also parallel. So A is parallel to C. And this one isn't a conventional name. It's one I made up because we're not using a textbook really. So it's parallel to the same line theorem is what I'm referring to it as. So this is using the parallel to the same line is parallel theorem. Okay. If you can't remember the name of the theorem, you're always welcome to describe what the theorem says instead of writing the name of the theorem. That would also work. Okay. So again, it's important that you make the distinction. Our original ones, we knew the lines were parallel, right? All of these had that the lines were parallel to begin with. And then on today's, we're showing that the lines are parallel by the angles being congruent or supplementary. Okay? Now, you can't show that something is parallel lines with vertical angles or parallel lines with linear pairs. You can still use that piece of information to help you get to other parts, but that doesn't show that lines are parallel. Okay? So make sure you keep that in mind. And then we have if one line is perpendicular to another one, if two lines are perpendicular, let's say, if one line is perpendicular to a set of parallel lines, then it's perpendicular to the other one. Sorry. And then if two lines are parallel to the same line, then those two lines are parallel themselves. Okay? So we've got those extra pieces of information that we have as well. We could go about proving both of those with the things that we know already. We're going to look at going about proving things at a later point in time.